So, a very good morning to all. I hope my voice is audible to all of you, right? So, this is the second class for the hydrocarbon problem solving. So, in the first class, we already, solved some very important questions related to NEET and JEE mains. So, in this class also, we are going to continue the same, and we are going to solve some more previous year questions related to this hydrocarbon problem, right? Basically, in last 5 6 classes, we are solving numerical related to only GOC and hydrocarbon only, because these chapters play a very crucial role, because these their weightage is very high. So, and this is the basic concept you needed for the organic chemistry to be very strong. Okay. So yeah, all of you, chalo. So let's start with the question. The first question is, that is, identify Z in the sequence of reaction, right? So you have to identify Z in the sequence of reaction. What is Z for this reaction? Yes, beta, all of you, sub join कर लो फटाफट जल्दी से. So we wait for a 1 minute, right? Then we're going to start. सभी लोग join कर लो. 1 मिनट और वेट करते हैं सबको ज्वाइन करने का. Then we're going to start. ठीक है, चलो. So, in this question, you have to identify Z in the sequence of reaction. So here we have alkene, right? So this is alkene, and we all know that when the alkene is treated with the HBr in presence of peroxide, this is known as anti-Marconics rule. So after anti-Marconics rule apply, you'll get the intermediate Y. When you treated Y with the C2H5ONA, you'll get the final product, that is Z. So you have to calculate Z only here, right? So let me, uh, yeah, this is CH3, this is CH2, this is CH double bond CH2. So we are with 1, 2, 3, 4, but 1 ene, right? When but 1 ene is treated with HBr, because peroxide is present, that is H2O2. So according to the anti-Marconics rule, the negative part goes to those carbon atom which contain the lesser number of hydrogen atom, right? So this Br goes to which atom? CH2 or CH? Can anyone tell me? According to the Marconics rule, the negative part goes to those carbon atoms which contain the lesser number of hydrogen. But in anti-Marconics rule, just reverse of this, the negative part to those atoms which contain the more number of hydrogen. So this Br2 goes to this CH2, and this H will go here. So क्या मिला final product, that is CH3. This will become CH2. Again, we have CH2, and this is CH2Br, that is bromobutane. So we left with the bromobutane. Then this bromobutane is treated. This bromobutane is treated with the C2H5ONA. ONA. Then what happens, beta? When this C2H5, this will treated with the ONA, then obviously NaBr will be removed. Huh? So what product you will get? So we'll get product like CH3, CH2, 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 and NaBr is removed. So O, and this is CH2. Product क्या निकला है? That is NaBr. NaBr. So this is the final product, right? This is the final product, that is CH3, CH2, CH2, OCH3. So which option is correct, beta, out of this? So yeah, this one, because CH3 and CH2 three types, 1, 2, 3, and OCH2, CH3. So option A is absolutely correct for this. ठीक है. So I hope समझ आ गया होगा सबको ये. कि ऑप्शन ए क्यों है करेक्ट इसके लिए, राइट। चलो, वेरी गुड। Now, move to the next question, beta. That is, which of the following organic compound has have same hybridization as its combustion product of CO2? Right. So, out of these, ethane, ethine, ethene, and ethanol, you have to calculate which of the following organic compound have the same hybridization as its combustion product of CO2. Right. So, you all know that whenever the hydrocarbon are treated with the O2, that is called combustion reaction, will get CO2 plus H2O, right? So we all know CO2 having hybridization, CO2 having hybridization. So hybridization we can calculate by knowing the number sigma bond plus lone pair of electron. So here we have only one sigma bond because in double bond one sigma and one pi bond are present, right? So this is known as, here we have one sigma bond, here also we have one sigma bond, right? So total we have a two sigma bond plus zero lone pair, right? Two sigma bond plus zero lone pair. This is very much clear. So the hybridization is nothing but sp. Hybridization is sp, right? Now ethane, we all know that ethane having hybridization sp3, ethyne having hybridization sp, ethene having hybridization sp2, ethanol having hybridization sp3. Huh? So which of the following is correct, beta? Obviously ethyne, because CO2 having hybridization sp and ethyne also having hybridization sp. This thing everyone know na, why how we can say that ethane having sp3 hybridization, ethine having sp3 hybridization, because we know this thing, carbon carbon single bond having always sp3 hybridization, carbon carbon double bond sp2, and carbon carbon triple bond having sp3. Let me calculate for ethine. So for example, this is ethine we have, right? So what is the hybridization of carbon in case of ethine? So we have carbon carbon one sigma bond here plus one sigma bond with hydrogen. So total two. So two means again sp, right? So we can say that hybridization of carbon in ethine is sp. So this is the correct answer, ethine. Everyone got it or having doubt? Anyone having any kind of doubt in this question? No? All clear? Chalo. So move to the next question. Now we are going to see some JEE mains particular questions, right? That yeah. So a hydrocarbon X with the this question came in 2023, right? JM in 2023, last year itself. So a hydrocarbon X with the formula C6H8 uses 2 mole of H2 on catalytic hydrogenation of its 1 mole. On ozone X, give 2 moles of methane dicarboaldehyde. You have to identify this X. What is this X? Right. So you have to identify. So first of all, a hydrocarbon with the formula C6H8. So remember one thing, beta. It's obviously C6H8. So whenever number of carbon, what is the formula of alkane? We all know this thing, na? What is the formula of alkane? That is C6 H14. Always 2n plus 2. What is the formula of alkene? That is C6 and this will be H12. Now what is the formula of alkyne? That is C6 and twice minus 2. That is 12 minus 2. That is H is going to be 10. So this is neither alkane, neither alkene, neither alkyne. So this thing is very much clear. So it must be a cyclic compound, right? It must be a cyclic compound. So let me explain this thing. That is this hydrocarbon having formula C6H8 and uses 2 mole of H2 on catalytic hydrogenation of its 1 mole, right? Catalytic hydrogenation of its 1 mole on ozone lysis X. जब हम इसको ozone lysis करते हैं on ozone lysis X, it gives 2 moles of methane dicarboaldehyde. You have to identify this, right? So if this is cyclo, because 6 carbon is there now. So if this is cyclohexene, cyclo and cyclo 1,4, cyclo 1,4 die, right? Because we get in the product methane dicarboaldehyde, right? Methane dicarboaldehyde. So on ozonolysis, the reaction with the O3, in presence of zinc and H2O. ठीक है? So reaction with the O3 in presence of zinc and H2O. So we'll get definitely we'll get the 2 mole of dicarboaldehyde, right? Because here we get one aldehyde, here also we get one aldehyde. ठीक है? So we'll get 2 mole of H C double bond O CH2 C double bond OH. Right. So the correct hydrocarbon is cyclo 1,4-diene. So which of the following option is correct, beta? That is B. So because in this question we have to identify the hydrocarbon, that which hydrocarbon we are using. So in this we are using cyclohexa 1,4-diene. Why only 1,4-diene, beta? Because in this only we'll get the 2 moles of methane dicarboaldehyde. Okay? 2 moles of methane dicarboaldehyde. Done. Look at here we have a 1, 2, and 3 carbon, and there's a 2 mole. So 3 to the 6 carbon. So all 6 carbon are used. Now move to the next question, beta. That is, choose the correct set of the reagent for the following conversion. So we have to convert, that is phenyl and CH double bond CH3 alkene into cis form. So you have to convert this trans form into cis form. So let me draw the structure first. So we have a cis form like C double bond C, and here we have in trans form. So this is PH again, this is H we have, this is again H we have, and this is nothing but CH3. So this is the transform, right? Now, when they are treated with Br2, when they are treated with the Br2, we all know that when the alkene is treated with Br2, what happened, right? So simply, this is become pH, this is CH, यहाँ Br लग जाएगा और एक Br लग जाएगा आपका यहाँ. So we get the 2 bromo, right? And this will become CH3. So this is a simple addition reaction with Br2. Hmm? Now, when they are treated next with the alcoholic KOH, that is alcoholic KOH in presence of NaNH2, in presence of NaNH2, alcoholic KOH and NaNH2. What they form, beta? Basically, they will form PHC. Here we'll get a double bond or triple bond. Can anyone tell me? Triple bond, beta, right? C triple bond, and this is CH3. So byproduct क्या निकल गया यहाँ से? 2 KBr and H2O is also removed. So we'll get this. Now, when this is treated with Lindlar catalyst, when they are treated with the Lindlar catalyst, Lindlar catalyst. Always remember, beta, whenever they are treated with Lindlar catalyst, you'll get the cis. Whenever they are treated with the sodium in liquid ammonia, we'll get the transalkene, right? So this thing you always remember. So we'll get a C double bond C. Here we'll get PH. Here we'll get CH3. Here you'll get H, here also you'll get H. So this is known as cis, right? This is known as the cis form. So which set of reagent we are using? First, we are using Br2. Secondly, we are using alcoholic KOH and NNS2, and then Lindlar catalyst. So which option is correct, beta? That is A. That is Br2, alcoholic KOH, NNS2, H2, and Lindlar catalyst. When you are using Na in liquid ammonia, then you'll get the transalkene. Always remember, you'll get transalkene. So these two things must be clear. Whenever you are using Lindlar catalyst, you will get cis. Whenever you are using transalkene, sorry, whenever you are using sodium in liquid ammonia, you'll get a transalkene. Okay? So this is how it reaction takes place. So this is the correct set of the reagent that we are using. Now move to the next question. That is the one giving the maximum number of isomeric alkenes on dehydrohalogenation reaction is excluding rearrangement. Yani you do not need to uh, include the rearrangement. So you have to identify the one giving the maximum number of isomeric alkenes on dehydrohalogenation. So we all know this thing. What do you mean by this term dehydrohalogenation? Right. For example, if you are here, we have a 2 bromo 3,3 dimethyl pentane. Here we also have a 2 bromo propane. Here in this case, we have a 1 bromo 2 methyl butane. And this is the N है मतलब this is a N bromopentane, right? We can say that this is a 2 bromopentane. So let me draw the structure first. For example, if this CH3, H2, this is again CH, CH3, CH2 and Br. So this is an example of a 2-bromopentane, right? This is example of 2-bromopentane. So from 2-bromopentane, when we treat with the dehydrohallucination reaction, means treating with KOH, alcoholic. So KOH alcoholic, what happened? KBr is removed as well as H2O is also removed, right? So KBr as well as H2O. So both this KBr and H2O will be removed, right? So what product you will get with actually? So you will get the product like C, again C, here we also get C and double bond C, right? So this product you will get. So this is the first form. So in this their question is asking the one giving the maximum number of isomeric alkenes, right? So this is the first alkene. Again, if you are using a compound like this, that is a CH3, CH, and this is Br, CH3, then you will get what then you get? If you're using the 2-bromopropane, then you will get only this, that is CH3, CH, double bond, CH2. Then you will get only this type of alkene, right? Then you will get this alkene. Now, when you are using that is the D, that is a 2-bromopentane, right? 2-bromopentane. So this is the when you are using 2-bromopentane. Let me explain this thing here. ठीक है, यहाँ पे एक्सप्लेन करता हूँ इसको दोबारा से. Right, when you are using 2-bromopentane, so let me draw the structure of 2-bromopentane. That is a CH3 we have, CH2 we have, CH2 we have, this is CH, here we have a Br, and this is CH3. So this is the structure of 2-bromopentane. Now when the dehydrohallucination of 2-bromopentane takes place, then it will form minus KBr is removed and minus H2 is also removed, right? So this is the alpha carbon. So this must be a beta carbon, right? So you'll get the two type of product, right? Either we'll get C, 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 C and double bond C from this carbon, right? Or we get C, C, C and double bond C and C. So we'll get the two type of product, right? Either we'll get this or either we'll get this. That is a cis and transform. So we'll get the maximum number of isometric alkene in the 2-bromopentane, where in all these three cases, that is a 2-bromopropane and 1-bromomethyl butane, gets only one type of alkene. So this is the correct answer, beta, because in this they are asking the one give the maximum number of isomeric alkanes. So which will give the maximum number of isoalkane? That is a 2-bromopentane. So 2-bromopentane will give the maximum number of isoalkenes on dehydrohallucination reaction. Clear है सबको ये चीज? Right? So this will give us the maximum number of isomeric alkenes on dehydrohallucination reaction. That is a 2-bromopentane. Now move to the next question. That is the correct sequence of reagent for the preparation of Q and R is. So you want to prepare Q and you want to prepare R. So what are the current sequence of reagent that you are using for the preparation of this, right? So let me explain the whole reaction, then only you get to know that which set of reaction we are using for the preparation of this compound, right? So for example, we all know this thing. Whenever we have this type of compound, like this is known as a 1, 2, 3, 4, 5, 6, 7. So this is known as a heptane, right? So this is known as a heptane. N-heptane, we can say that. So can we draw the structure like this? For the example, we have N-heptane. So we all know that now, whenever the N-hexane is treated, N-hexane is treated with the Cr2O3 in the presence of 770 Kelvin, will get benzene, right? Whenever this is treated with, will get the benzene in the presence of some high temperature and pressure. So this is a very much similar to this reaction. So if the six carbon are treated, we'll get benzene. Here we have a seven carbons, and obviously we'll get toluene, right? So when we treat this, when we treat this, right? So we have a one carbon, two carbon, three carbon, four carbon, five carbon, six carbon, and this is seven carbon. So when you treat this with Cr2O3 at 770 Kelvin, right? 770 Kelvin and 20 atm. ठीक? So when you treat with the Cr2O3 at 770 Kelvin and 20 atm, you'll get toluene. क्या मिलेगा? You'll get toluene, that is CH3. ठीक है? You'll get toluene. Now when this toluene is treated with the CrO2 Cl2, right? CrO2 Cl2, and on further hydrolysis, what you'll get, beta? You'll get benzaldehyde. You'll get benzaldehyde. We all know this thing, Itard reaction this is. So you'll get CHO. Whenever the toluene is treated with CrO2 Cl2 in presence of some acidic hydrolysis, you'll get the toluene. Now, when this toluene is treated with NaOH, sorry, when the benzaldehyde is treated with NaOH, we know what we'll get. We'll get this compound, right? Because this is a benzaldehyde and this will undergo which type of reaction? That is the Cannizzaro reaction, beta. Yes, that is a Cannizzaro reaction in presence of NaOH. So what you will get? You'll get your desired product, right? You'll get your desired product this CH2OH, and this will get first step NaOH and second on hydrolysis, right? H3O plus. So you'll get the product like COOH. So which of the following is the correct reagent, beta? Obviously A. So A is the correct sequence for the reagent that used for the preparation of P and Q. That is the Cr2O3. When you treat with the Cr2O3, we'll get a toluene, right? This reaction is also known as the aromatization, right? We'll get the toluene. When we treat toluene with the CrO2Cl2, we'll get benzaldehyde. When you treat benzaldehyde with the NaOH, then we'll know this is a Cannizzaro reaction. You are going to study this reaction in class 12, aldehyde and ketone chapter, right? So don't worry for this. We are going to see this Cannizzaro, aldol, all this reaction in the 12th class, right? So this is all correct sequence of the reagent that we are using for the preparation of Q and R. Chalo. Move to the next question. In this question, they're asking arrange the following in increasing order of reactivity towards the nitration, right? Towards the nitration. So, for nitration, what is nitration basically? So, when you treat benzene, I'm giving you the simple example of nitration. When you treat benzene with concentrated HNO3 plus H2SO4. So when you treat benzene with concentrated HNO3 and H2SO4, what we will get? We'll get nitrobenzene. We'll get nitrobenzene. And from this concentrated H2SO4 and HNO3, we'll get the electrophile NO2 plus. Right, this NO2 plus attack on this benzene ring to form nitrobenzene. So this is the basic mechanism of the nitration. Now, in this question, they are asking, arrange the following in increasing order of reactivity towards the nitration. So, we have a paraxylene, huh? And we have a bromobenzene, we have a mesitylene, nitrobenzene, and we have benzene also, right? So, we all know that as the electron donating group increase, right? Because NO2 is electrophile. So electrophile attack on the benzene ring. So when electrophile feel comfortable, very comfortable to attack on the benzene ring, when the electron density in the benzene ring is very high, right? Because electrophile wants electrons, right? What are the meaning of electrophiles? They are the electron loving species, right? So they want electron. So they try to attack on those compound they having the maximum density of electron, and whenever the electron donating group is attached to the benzene ring, they always try to increase the electron density, right? So electron donating group increase electron density, and electron withdrawing group decrease electron density on the benzene ring, right? So these two things is very much clear. That is, electron donating group try to increase the electron density, and electron withdrawing group try to decrease the electron density, right? And electrophile electron loving species, so they want to attack to those having electron donating groups, and where the reaction is very easy. So in this we have mesitylene, and also we have paraxylene, and next we have that is mesitylene, paraxylene, bromobenzene, nitrobenzene, and benzene. So let me draw the structure of all of these things. So first of all, let me draw the structure of nitrobenzene. So this is nitrobenzene, that is NO2. Then I will have to draw the structure of bromobenzene. So here we have bromobenzene. Hmm? Then we need to draw the structure of benzene. फिर आ गया हमारा benzene. Then after benzene, we have we have paraxylene. So what is paraxylene, beta? Paraxylene means they having CH3 group, right? So this is known as paraxylene. And then we left with metis, that is mesitylene, right? So structure of mesitylene, like here we have a CH3. Again, we have a CH3 at meta position. Here also CH3 at meta position. So this is known as a mesitylene. Okay. Now, out of these, maximum number of electron donating group is present at this compound. Maximum number of electron donating, that is 3. Then comes this 2. Huh? In this no donating group, but also mention no withdrawing group is also not present, right? So neither withdrawing group, neither donating group is present. In this, we have a one withdrawing group, bromine, and here we have a withdrawing group, NO2 also. NO2 is a highly withdrawing group as compared to Br. So what is the order of nitration? We already know. More number of electron donating group attached to the ring, high electron density, and easily attack of NO2 will be takes place. So obviously order is like this. This is much, this, and this. So what is the correct order, beta? That is the maximum is for C, right? And minimum is for nitrobenzene, that is D, right? So which is the correct option? That is B. So B is absolutely correct answer for this question. Okay. So I hope this is clear to everyone. सबको क्लियर है क्या? एक बार कंफर्म कर दो. This is very interesting question, beta. Right? चलो. So let's move to the next question. ठीक है? Okay. So in this question, uh, we have a free radical of chlorine that react with CH4 to form A plus B. So you have to identify A and B. A, B in the above atmospheric reaction steps are. So you have to identify the A and B. So we all know this thing. This is a very simple, and we can say that this will be study in the mechanism of the substitution reaction, right? That is the free radical substitution reaction mechanism, under which we already studied this thing. That is, whenever the CH4 is treated with the free radical of chlorine, then what happen? They will form the free radical of methyl as well as HCl, right? They will form the free radical of methyl, and HCl will be formed. So what is A and B they are asking now? So A and B are nothing but CH3 and HCl. So option C is absolutely correct, right? This is a very, very simple question. Chalo, move to the next. That is a compound A on 3 reaction with X and Y produce the same major product but different by the product A and B. An oxidation of A gives us the substance produced by ants, right? So you all know this thing. Ants produce what? That is formic acid, huh? So ants produce formic acid basically. So this clue we are going to use. So first of all, a compound A on reaction with X and Y produce same major product but different byproduct A and B. ठीक है, and oxidation of A and B give us substance produced by ants. So you have to identify what is X and what is Y in this reaction, right? So you have to identify this. So this is very very interesting question. ठीक है, चलो देखते हैं फटाफट solution इसका. So we have let me draw the structure. We have H2C double bond C CH3 CH2 C CH3 CH3. Here again we have CH3, right? So we have CH2 double bond C CH3 CH2 C CH3 CH3 and CH3. This is a compound A. Now when we treat this, because what you'll get, we'll get here we'll get a ketone, one molecule of ketone, right? Here also we'll get the one molecule of ketone, hmm? Plus A and B, A as well as B, right? So, very interesting note here. This must be a ozone lysis because I already explained this thing. Whenever we have double bond, कैसे तोड़ना है इसको? ऐसे तोड़ो. एक O इसको दो, एक O इसको दो. ऐसे ही तो करना है. अब देखो. Here we have alkene like this. So one part will get as a ketone, obviously because there is no hydrogen. So we'll get ketone like this. That is C double bond O. Here we have CH3, CH2, C, CH3, CH3, again CH3. And here what you will get, that is HCHO, HCHO, formaldehyde, right? Here also we'll get the same thing, formaldehyde. Now when this formaldehyde is treated, right? When this formaldehyde is treated with KMNO4 oxidation, then formic acid will be formed. Then what form? That is formic acid. So which of the following is the correct set of reagent beta? Because how will know formic acid? They already given. Oxidation of A gives a substance produced by ant. यानी oxidation of A जो होगा वो क्या दे देगा? Substance produced by ant. So you have to identify this X and Y. So here X is and Y is O3H2O, that is ozone lysis and the oxidation by KMNO4. So which is the correct option? That is D. So D is the correct option. ठीक है? So D बिल्कुल ही correct option हुआ इसके लिए. That is O3H2O in presence of zinc and KMNO4. Right? So this is the correct sequence. Everyone got it? समझ आया सबको क्या? एक बार बता दो. Anyone having any kind of doubt, you can ask again. Clear है? Right? Chalo. Now, move to the next question. That is two isomers A and B with the molecular formula C4HX give the different products on oxidation with KMnO4 in acidic medium. Isomer A on reaction with KMnO4H result in the effluence of a gas and give ketone. So यहाँ पे एक CO2 निकल रहा होगा, effluence का मतलब, and form ketone. The compound A is. So you have to identify the compound A. So two isomers A and B with the molecular formula this give the different product on oxidation with KMnO4 in the acidic medium. The isomer A on reaction with KMnO4 acidic medium result in effluence, मतलब release of CO2 gas and give ketone. ठीक है? So you have to identify this A. So let me, we have a C4H8 only, na? C4H8 only. So we have like CH3, C. Again we have CH3, double bond CH2, right? So this is what we have. That is 2-methyl propene. 2-methyl propene, right? When this 2-methyl propene is treated with KMNO4 in acidic medium, they will form CH3, C double bond O, CH3, as well as CO2. So, which of the following compound is correct, beta? That is 2-methyl propene. Because whenever the propyl propene is treated with KMNO4 in the acidic medium, they will release CO2 gas. So the formation of ketone plus CO2 gas will be takes place. ठीक है? चलो. So move to the next question. So given below are the two statements, statement 1 and statement 2. So the first statement is the presence of weaker pi bond make alkenes less stable than alkenes. Okay. The next is the strength of the double bond is greater than the carbon-carbon single bond. So you have to identify out of these which option is correct, right? So we have given below the two statement and you have to identify which statement is correct, right? So the first statement is the presence of weaker pi bond make alkenes less stable than alkenes. So obviously, by if we have a carbon-carbon double bond, in this we have a pi bond. So pi bond are loosely bond, right? ये बहुत ही loosely bonded होते हैं. तो pi bond are loosely bonded. It means yes, they are the weaker, right? So presence of weaker pi bond makes the alkenes less stable than alkenes, right? So that makes the alkene less stable than alkenes. Therefore, the statement one is absolutely correct because their bond are loosely bonded. They're very loosely bonded. They're very weaker bond. So they make them alkene less stable as compared to alkane. So statement 1 is absolutely correct. Now statement 2. So we all know that the carbon-carbon double bond is stronger than carbon-carbon single bond. So the strength of the double bond is greater than the strength of the carbon-carbon single bond because more energy is required to break one sigma bond and one pi bond than to break one sigma bond only. Therefore, the statement 2 is also correct, right? Because look at carbon carbon double bond, carbon carbon single bond. So we know carbon carbon single bond we have a sigma bond, but in this we have a sigma bond as well as pi bond, and we know that sigma bond is stronger than pi bond. So in this one sigma bond is present only, but in this sigma bond as well as pi bond also present, right? So that's why more energy is required to break the bond in carbon-carbon double bond, right? That's why the strength of the double bond is greater than the strength of the single bond. So this statement is also true. So both the statement 1 and 2 are correct. So A is the correct option. Okay? That is the presence of weaker bond, which is also correct in case of alkenes. And the strength of the double bond is more as compared to the strength of the single bond. Okay? Now, move to the next question. So in this, we have this compound that is alkene, and you want to convert this into aldehyde, right? So which you are basically using PCC oxidation, ozone lysis, and BH3H2O2H followed by the PCC oxidation or HBr. So we are not using PCC oxidation because the oxidation of alkene is not possible to give CHO, right? Then only oxidation of alcohol will take place to give the CHO, right? The second is ozone lysis. So if you are using the ozone lysis, then what happen? we'll get one O to this compound, one O to this compound. Then we'll get HCHO. That is formaldehyde, not benzaldehyde. So this is also not true. So this not true. Now the next is BH3 followed by H2O2. So we all know that this is a hydroboration oxidation which follow the anti-Marconics rule. So what happening when you treat this with the BH3 in presence of peroxide, right? What happening basically? So this will form that is formation of CH2 and OH, right? Formation of CH2 and OH. That is we have a OH H2O na. So we have OH negative and H plus. So H negative goes to those carbon, H plus goes to this carbon, this one, right? So we'll get the CH2OH, which on PCC, which on PCC oxidation give us benzaldehyde, which on PCC, not benzaldehyde, but the aldehyde group is attached to it. That is a cyclo. Okay? Cyclo aldehyde group. So the correct option is beta C. So C is the correct option because by using BS3 and H2O2, by using anti-Marconics rule, also known as the hydroboration oxidation reaction. So by using hydroboration oxidation reaction, we'll get this alcoholic group attached to this OH. And when this OH is treated with PCC, we'll get this CHO group attached, right? So the correct option is C. Now, next is for the following sequence of reaction, the correct products are. So for the following sequence of reaction, what are the correct products are, right? You have to identify the correct product. So we have a benzene, right? So this is a step-by-step reaction. So we are with benzene. Hmm? Now this benzene is treated with Br2 and Fe some heat in the first step. So what they form, we all know this, they will form bromo, right? They will form bromobenzene. They will form bromobenzene. Now when this bromobenzene is treated with Mg and dry ether, obviously Grignard reagent will be formed. Obviously Grignard reagent will be formed. Then this will form MgBr. MgBr. So MgBr will be formed, Grignard reagent. Now when this Grignard reagent is treated with CH3OH, then only H, that is benzene, and this is MgBr, and this is OCH3. So we are left with benzene only. So which of the following is correct, beta? That is option A. That is benzene plus Mg, OHCH3 and Br. So this is a simple reaction from till here to till here, Grignard region. Just remember one important reaction here. That what happened when the Grignard reagent is treated with the alcohol, that is CH3OH. So whenever this treated with the CH3OH, we'll get the product like this, right? That is benzene plus MgBr OCH3. Now move to the next question. That is presence of which reagent will affect the reversibility of the following reaction and change it to a reversible reaction. Okay? So presence of which of the following reagent will affect the reversibility of the reaction. So we all know this thing. This is a very simple question. That is iodination is always reversible in nature. So whenever we do iodination, this is always reversible in nature. Why? Due to the formation of this Hi. So due to the formation of this Hi only, this reaction is reversible. So we have to add an oxidizing agent because this Hi is reducing in nature. So we have to add an oxidizing agent called, HiO3. We are using basically, we are using HiO3, right? So concentrated HiO3 we are using. This HiO3 convert this into I2 and H2O. So the formation of Hi will be removed because this Hi is only responsible for the reversibility of the reaction. and they are reducing in nature. So we have to add an oxidizing agent like HiO3. And what HiO3 do? HiO3 converts Hi into I2 and H2, right? That's why that is a concentrated HiO3 is used. So this is a very simple question, and this question is from the mechanism of the substitution, free radical substitution reaction only. Okay. So I hope everyone got this question. Hmm. Chalo. Move to the next. That is an organic compound A having formula C4H8 on treatment with KMNO4H yield compound B. Right. And compound A also give compound B on ozone Compound A is. Right. So you have to identify the compound A. So it's a very simple thing. That is an organic compound A having the formula C4H8. Right. So if we have a compound like that is a 2-methyl propene. 2-methyl propene. So let me draw the structure. 2-methyl 2 we are having methyl 2-methyl propene, right? So this is the structure of 2-methyl propene. So if we have a 2-methyl propene and this when this treated with KMNO4, अभी अभी देखा था ऐसा क्वेश्चन सेम टू सेम. KMNO4 and acidic medium, they will convert this into what? That is ketone. That is CH3 C CH3 double bond O we have. So this is ketone C3S6 336 and CO. So we have a ketone. Also, when they are treated with the ozone lysis, right? O3, then again they will form CH3 C CH3 double bond O plus formaldehyde. Right. So in this question they are saying A also yield compound B on ozone lysis. So compound A is. So obviously the compound A is 2-methyl propene. Only 2-methyl propene when they are treated, they will form ketone, that is acetone, right? So this is the correct one, that is a 2-methyl propene. Now, the next is metallic sodium does not react normally with. So you have to identify the metallic sodium does not react normally with. The first is gaseous ammonia. The next is but2-ine, and the next is ethine and third butyl alcohol. So metallic sodium does not react with, right? So out of these four options, which is correct? So always remember, beta, 2-butene does not have an acidic hydrogen, right? So that is but2-ine. So metallic sodium does not react with, because we know this, we use the reaction of metallic sodium to confirm the acidity, right? So but2-ine, that is C, yeah. So this is the structure of but2-ine. So they do not have any acidic hydrogen. So metallic sodium does not react with the 2-butene, because 2-butene does not have any acidic hydrogen. So they do not have, they do not have acidic hydrogen. They do not have acidic hydrogen, so they do not react with this. So but2-ine is the correct answer. Okay. Now, benzene or nitration give nitrobenzene in presence of HNO3 and H2S mixture, where both HNO and H2SO4 act as a base. No. HNO3 act as an acid, where H2SO4 act as a base. Both H2SO4 and HNO3 act as an acid. Yeah, HNO3 act as a base and H2SO4 act as an acid. So you have to identify which of the following is the correct statement, right? This is question from the mechanism of nitration. So we all know this thing. That is HNO3. What happened basically? So here we have a H2SO4. When this H2SO4 react with HNO3, what they form? They form HSO4 negative plus H2NO3 positive, right? In the next step, this H2NO3 is converted to H2O plus NO2 positive. This is electrophile in this reaction, right? So here we have this act as an acid, this act as an base, right? So HNO3 act as a base and H2SO4 act as an acid. So this is the correct one. ठीक है? So I everyone got this? सबको समझ आ गया होगा? So we discuss a lot of question from this chapter. ठीक है? बहुत सारे question हम लोगों ने डिस्कस कर लिया ऑलरेडी. तो यही सब क्वेश्चन थे जो डिस्कस करने थे. दीज टाइप ऑफ क्वेश्चंस ट्राई टू सॉल्व ऑन योर ओन सेल्फ. और these all are the very very important questions, to try to solve more and more question. And if you practice more question, then definitely you get the result. Okay. So anyone having any kind of doubt in today class, you can ask now. Right. So that's all for today class. अगली class से मिलते हैं. Then we are going to discuss some more important question. Right. So thank you all.